Hey guys, welcome to another video. Today's learning objective is all about completing the square and using that to find turning points. As usual, feel free to skip to any part of the video thanks to the timestamps here. But yeah, let's get into it. So, there's this term here in the learning objective, completing the square. What does that mean first? Well, okay, completing the square. What that means is to take a quadratic, so if we've seen this before, for example, quadratic like x squared plus 5x, or actually let's say 2x squared plus 5x plus 7x, into the form of, say, x plus a squared plus b, for example. Okay, so say if we wanted to factorize the quadratic x squared plus 4x plus 3 into this form, x plus a squared plus b. Okay, well, let's square out this term here first. So x plus a squared, well, we can write that as x plus a times by x plus a plus b, which comes out to x squared. So if we do this slowly, it comes out, x times x, and then x times a, so plus ax, and then x times a again here, so another ax, and then we've got let me change pen colors, then we've got a times a plus a squared, and then we've got the b, right? Okay, so then we can rewrite this as x squared plus 2ax plus a squared plus b. Now, if we look at this on the left-hand side, we've got x squared plus 4x plus 3. And now let's look at the coefficients for each of the terms. So x squared, there's a coefficient of 1 here, and there's a coefficient of 1 here. So we can ignore that right now. But if we look at the coefficient for the x term, we've got a 2a here and a 4 here. And that's the only coefficient for x on the right-hand side, and the only coefficient for x on the left-hand side is the 4. So we know 2a is equal to 4, which means that a is equal to 2. Now we have that, we know also a squared plus b is equal to 3. Because if we compare the right-hand side to the left-hand side. Okay, so let's do that. If a squared plus b is equal to 3, we know a squared, a is 2, so 4 plus b is equal to 3, and b is equal to then minus 1. And so we can write this as, if we wanted to complete the square, it would be something like x squared plus 4x plus 3 is equal to then x plus, remember the form, x plus a squared, so x plus 2 squared plus b, and b is minus 1, so plus minus 1, which is listed as x plus 2 squared minus 1. And so this is the long way of doing it. There's actually a bit of a quicker way to do this. If you notice that this a term here, remember in this x plus a term is always going to be half of this term here, because you have 2a here, and then you have whatever here, so you just divide that by 2. So first thing you know straight away, then if you want to factorize this, right, you can say straight away that you're going to have x plus half of this term, so x plus 2, then you square it. And now when you square this out, right, you're going to get the x squared plus 4x plus 4, right? So if we square this out, let's square that out. That comes out to x squared plus 4x plus 4. But we only need a 3, right? So what we can do is then we have this extra 4, right? So we can take away 4 from here, but we need to add 3 because that's what we need to end up with, so we do that. So in general, what you do is you look at this quadratic here, you go x squared plus 4x plus 3, and so this is like the algorithm behind it, or like the way you can do this really quickly without really thinking about it and expanding this out like here. But if you ever do forget, just remember completing the square is this form here, and you just need to expand it out to figure out what goes where. But the algorithm is basically this. You have your x, so you write it as x, and then you have half of this plus 2, and then you square it, do that, and then you minus this term squared, so you go minus 2 squared, which is minus 4, and then you add this term here, plus 3. So let me do that in colors. So that goes to there, and you minus, and then you've got the 3, and then you add the 3. So let's do another one just to see if we have it. So say we have something like, we need to complete the square on x squared plus 8x plus 13. So why don't you pause the video for a second and try to kind of figure out what this might be. Try to remember our algorithm here, or if you've forgotten it, just remember that we have to go to get it into a form of x plus a squared plus b. And then you can kind of expand this out and see what the right hand side and kind of left hand side by comparing the coefficients. Okay, so let's remember the algorithm. So we keep the x here, then we half this term. So half of 8 is 4, so we do plus 4, square that. Then we minus this term here, minus that square, so we go minus 4 squared. And then we add this last term here, the constant term, which becomes 4 squared minus 16 plus 13, which is x plus 4 squared minus 3. And there you go. So this is just kind of a simple algorithm, I guess. So you just need to practice this a few times to kind of understand to kind of get in the habit of doing these and kind of completing the score quite quickly then. What in the case if we have something like, for example, 2x squared plus 18x plus 19, what we actually have to do, instead of because of the coefficient of the x squared term isn't 1, you have to do something a bit differently. What you do is, so you get this initial part and you factorize out the coefficient in the x squared term. So in this case, you'll get in the form of 2, and then you go x squared plus, and then 18 divided by 2 is 9, plus 9x plus 19. So you do this is the first step you do. And now it's kind of the same algorithm. So you go 2, and then you can have this big bracket. So you do, in here, you have x plus, so you do the you half this. So you can do the x plus half of this, so x plus 4.5, and then you square it, then you minus 4.5 squared, and you plus 19, and then you kind of just do what we did before. So you have 2, then x plus 4.5 squared, minus 2 times 4.5 squared, plus 19, which comes out to, and then 4.5 squared, I'll check this on the calculator, is 20.25, and then times that by 2, comes out to 40.5, minus 40.5 plus 19, which comes to 2x plus 4.5 squared, becomes minus 21.5. So in this case, remember, if we have a coefficient of x squared that isn't 1, we look at these first two terms, we factorize out the coefficient of x squared that isn't that's there. So we get it into a form of where the coefficient of x squared is 1, and then we've got what are the term here. We do our normal process again. And the key thing, a lot of the times what students make a mistake here is that we don't multiply this minus 4.5 squared by the 2. So you have to remember to multiply that out, and then just do it as you did before. If you didn't want to do it this way, what you could do is, if we say this is the same thing as 2 into x squared plus 9x plus 19 over 2, and then you could do the normal way again, and then multiply it out by 2 at the end. So you can get this as, so if I actually work through it, it becomes 2, and then you have this, so you're like x squared plus 9x. So remember, we half this term here, so we go x plus 4.5 squared, and then minus 4.5 squared, plus 19 over 2. And then if you work through this, that will come out to what we had before. So what we do is we evaluate this term and then just times it by 2 later. It's the same principle as this. So this is just the other way of completing the square. So we have to watch out when the coefficient of x squared isn't 1. That's quite crucial, and a lot of the time that's where some error does happen. As another quick work example that you can have a go at first, and then I'll walk you through it again. So we have something like 5x squared plus 70x plus 100. How would we do this? Just pause the video, actually give this a go. It's quite helpful to see if you have it or not. Okay, so what we can do here is we can factorize out the 5, because the coefficient of x squared isn't 1. We have to think about factorizing this out. So if we look at the 5, we can factorize out the 5 in the first two terms. So we go 5, and then you have x squared, and then 70 divided by 5 is 14, and then plus 100. And then we have and then we work through what we did before. So remember, look at this thing here. We go x plus half of 14, which is plus 7, square that whole thing, minus 7 squared, minus 49, close the brackets, plus 100 out here, which comes out to 5, x plus 7 squared, minus 49 times 5, plus 100, which is 5, x plus 7 squared. 49 times 5 is, 50 times 5 minus 5, which is 245, plus 100. So, and then minus 145. There we go. So that's the other way of doing it, for example. So, sorry, not really the other way, but kind of the way you do it when we have a kind of the x squared coefficient isn't 1. And now this is kind of if we look at the second part of the learning objective, this is used to find turning points. So if you remember from last video what turning points are, it's kind of, if you remember, look at a graph like a quadratic, we have a quadratic here, and then the turning point is kind of the lowest point. So it's kind of, the gradient, the graph is decreasing, and then suddenly at this point the gradient is no longer negative and starts to become positive again, so it starts increasing, so it's the turning point. So this is a positive quadratic, but if we have a negative quadratic, it turns out to like a sad parabola, or kind of a sad face, kind of happy face, sad face. And in this case, it's kind of, the turning point will hence be the largest number, and the turning point here will be kind of the smallest number we have. And now the question is, why does this form of x plus a squared plus b help us find the turning point? Well, let's go back to our original example. I've got it plotted here. If we look at this, the turning point here is minus 2, minus 1. So we look at our quadratic, our factorized form. We can complete the square form. We've got x plus 2 squared minus 1. And remember, the turning point is the coordinates at which the y value is the smallest. If you look at here, look, this is the turning point. The y value at this point is the smallest. So if you look at this, right, if you look at x plus 2, the smallest x plus 2 all squared can be is 0, because whenever you square a number, it comes out to a positive number. So if you have minus 2 squared, it becomes 4. If you have minus 10 squared, it becomes 100. So the smallest number you can get if you have if you have something squared is going to be 0. And the way you can get this to 0 is if x equals minus 2, right? Well, minus 2 plus 2 squared is 0 squared. So that's just 0, right? So that's kind of the way you can get this as small as possible, is if you put the minus of this number here. And so in that case, our x term will be minus 2, because that's the minus here. And our y value, if we put minus 2 in, well, we have x plus minus 2 plus 2 all squared, which is 0 squared, minus 1. So that's just 0 minus 1. So the y term is going to be minus 1, because this is what y equals, remember? So that's why that's why the completing the square form is so useful, because it allows us to evaluate the quadratic in a way that's or at least show the quadratic in a way that's really obvious to see what the smallest value could be. If we have, for example, a the negative parabola of this, if we had, say, the parabola was minus x squared minus 4x minus 3, well, let's see what that would look like. So minus, well, that's our original quadratic flipped around, but with this minus parabola, our turning point is the highest value possible. So let's again see why that works. So we complete the square on this. Well, it's the same thing as completing the square on the minus of this, of our original term. So that becomes minus of which was original thing, which is x plus 2 squared minus 1. If you go x plus 2 squared minus 1, which is minus x plus 2 squared plus 1. And again, if we want this to be kind of as large as possible, right, because there's a minus term here, if we want this to be large as possible, we need this thing to be as small as possible. So the same logic applies. The smallest this can be, the smallest x plus 2 can be is 0, x plus 2 squared can be 0, but since there's a minus term here, right, that's kind of the largest it can then be. So again, we put the minus of this, we go minus 2, and then we just evaluate what happens here, which becomes 1. And if we see, it's minus 2, 1. So that's kind of how using completing the square, we find the turning point. If kind of you forget this logic, just think, if we have the completing the square, if we have x plus a plus b, turning point is minus a, b. That's kind of it. So as long as you get this into the completing the square form, you can just look at this and know that the turning point is at minus a, and I just kind of walked you through the logic there. So hopefully that all made sense. If this is kind of a new process to you, it's really important to practice through this, just so you kind of get the hang of it, and kind of, so it kind of almost second nature. You just look at the question, you can be like, oh, okay, I kind of know how to complete the score really easily on this. And then also kind of try a few of these questions about where they ask you to show what the turning point is. But just remember, even if you forget the logic, you can always remember the turning point is kind of this formula right here. But yeah, hopefully that all made sense. And I'll see you guys in the next video.